Welcome to today's lesson. In this first tutorial, we will review factoring using a GCF. So we are still with our factoring, and ultimately today we will be factoring trinomials by the grouping method. But before we do that, I would like to remind ourselves of some important vocabulary and practice some problems that involve a GCF. The word factor, when I use it as a verb, means to rewrite something as a product, things that multiply together. For example, if I wanted to factor the number 21, I could rewrite it as the product of 3 and 7, because 3 times 7 equals 21. The word factor used as a noun, 3 is one of the factors of 21, and 7 is another factor of 21. The greatest common factor, or simply GCF for short, is the largest factor that's in common among all of the terms of the thing that we're trying to factor. This is the thing we should always look for first. We should train ourselves to always look for the GCF first, whether it's a number or a variable or both. When we find it, we factor it out, and we'll see what else we can do. And we're going to practice that in the first 3 problems. Another important thing to note in the next few tutorials is the difference between an expression and an equation. An expression does not have an equal sign. All of the problems that we're looking at today are expressions because there are no equal signs. All we can do with an expression is rewrite it into some other form. Today we're going to be rewriting these expressions into factored form. As opposed to an equation does have an equal sign. And when there's an equal sign, that means that we can solve it. But that's for a later tutorial. So let's look at our expressions today, and in particular our first 3 problems. It says to factor each expression by finding the GCF, the greatest common factor. So our first problem actually only has 2 terms, that's a binomial, and I'm looking for the things that are in common in each term. Well, I see the 2 and the 6, and I know that 2 goes into both of those numbers. I see x squared, that means that there are 2 factors of x, and I see x, that of course is only 1 factor of x. So the most that's in common is that 1 factor of x. When I find my GCF, which in this case is 2x, I'm going to introduce a set of parentheses, and I'm going to write what's left from our terms in the parentheses. Some people like to take our GCF and divide each term by it, so that's a good visual. So I've got 2x squared divided by 2x. The 2x is going to factor out. This 2x is going to factor out. And let's see what's left. 2 divided by 2 is a 1. X squared divided by x is an x. I don't really need the 1, so I'll just put the x. I'll put the plus sign in here. 6 divided by 2 is 3. And I had a factor of x, but I took it outside the parentheses, so now it's gone and there's no more x's in there with the 3. And that is how we factor using a GCF. If you're not sure, or if you want to check, you can distribute backwards. Take the GCF 2x and multiply it to x, and you get 2x squared, just like the beginning. And you take the GCF 2x and multiply it to the 3, and you get 6x, just like your beginning. So we are correct. Let's look at number 2. Let's look at our numbers first, 5 and negative 20 and 5. Well, I know that I can divide 5 out because that's in common. There are 3 factors of x here, there are 2 factors of x here, but there's only 1 factor of x here. So the most that can be in common is that 1 factor of x. So I'm going to be dividing out a 5x. If I start with the trinomial, I will end with the trinomial in the parentheses. If you want to put the 5x underneath each of the terms, I think that's a helpful visual. And let's see what will remain. 5 divided by 5 is a 1. X cubed divided by x would be x squared. I have my minus sign. 20 divided by 5 is 4. X squared divided by x. I have 2 factors of x and I take one of them out. That must mean that there's 1 factor of x remaining. I see my plus sign. And 5 divided by 5 is 1. X divided by x is 1. In fact, the same thing always divided by itself would be 1. There are 3 things left. Let's not circle this. I'm going to come back to this problem. And finally, our last one, I see a negative 3, I see a negative 15, I see a negative 18. Well, I know that 3 will divide evenly into all 3 of those. But because my first term is leading with a negative, I'm not going to factor out a positive 3. I'm going to factor out that negative 3. Let's see if anything else is in common. I don't see any variables on this last term, so there must not be a common variable this time. It must just be the negative 3. So I'm going to introduce my set of parentheses, and I'm going to be dividing each one of these terms by negative 3. Now watch out when you're dividing by a negative, because of course your signs will change. Negative 3x squared divided by negative 3 will be positive x squared. Negative 15x divided by negative 3 becomes positive 5x. And negative 18 divided by negative 3 becomes positive 6. Let's not circle this one either. We're going to come back to this problem. That's just a quick review of factoring using GCFs. That's the end of this tutorial, and I'll see you in the next one, and we'll practice trinomials by grouping. See ya.